Hi, welcome to this course. Myself Muhammad Yaqub. I am the founder of Scratchlearn. So now let us dive into the overview of the course. So actually it is a very real-time project in computer vision, that is smart face attendance system. So we all know that when it comes to smart face attendance system, in a simple overview, when we stand in front of camera, it will capture our face and then it will mark attendance for us. This is a very simple explanation, but how we can develop this project, what happened behind the scenes, so how we can develop our own face attendance system, that is what we are going to see in this project. There are 5 important modules present in this project. The first module is face enrollment. Whenever we are developing an attendance system, first we need to capture the faces whoever we are going to enroll. For example, if we are enrolling 5 students or 5 employees, okay, for each person we have to collect minimum 10 photos, 10 facial images of each member, okay, that all the photos, each member has to be put in each separate folder. That's the first step called face enrollment. That is the first module in our course. The second module is about face embedding extraction. Once face enrollment is done, in each folder of each person, there will be a couple of images, maybe 10 or 20 images per person. That will be enrollment process as we discussed. In embedding extraction process, what is embeddings means, when we store person facial images, we have to extract some useful information from the face. Let's say what is the distance between each eyes, what is the distance between nose and eye, what will be distance between nose and lip, like that 128 different features will be extracted from the human face, that we call it as a embeddings or the feature extraction from the face. So all these features that will be stored in a separate file called pickle file format, okay. So that is the second module we'll be seeing in the course. And then third module will be training. Whatever the features we have collected in this from the second module, feature embeddings, that we will train using the machine learning model, okay. So that is the third module we'll be seeing. Now in fourth module we'll be seeing facial recognition part. In previous module we have trained the facial recognition model. Using that model we can able to now recognize the each person with their names or ID. That will be our fourth module. And the final module will be Tkinter graphical user interface development. So whatever the model we have developed earlier, that is face enrollment and face embedding extraction and training and facial recognition, all these modules, the user-friendly graphical user interface will be developed with the help of Tkinter package. That is the final module will be.
We are going to use the Python programming language to implement our entire project. For that, we need to install a Python IDE. We are going to use only a specific version of Python for implementing our entire project. For that, we need to install Python 3.12. And if you have already installed any other version of Python on your machine, then it must be uninstalled from your machine. So let's see how to install Python on your machine. First, you need to go to Google and type in Python 3.12 py release. Then scroll down. Select the Windows installer 64-bit. Then simply click to run it. Then select Add Python to Path. Then click Install. Now Python is successfully set up on my machine. Then close it. Now we can go and check the Python version using CMD. py-hyphen version. On my system, the Python version is 3.120. Now we can go ahead and implement our project. Before implementing and executing any part of our project, first we need to install VS Code on your machine. And if you already installed VS Code on your machine, then that's perfectly fine. This guide is for those who have not yet installed VS Code on their machine. Let's go through it step by step. VS Code is a platform that makes it easy to build applications. To install VS Code on your machine, first you need to go to Google and type VS Code. Then press Enter. Select Visual Studio Code from the results. Then click on download for Windows 10 and 11. Now the download has started. We need to wait a few seconds for the download to complete. Now VS Code has been successfully installed on my machine. Then I go to the folder. Then right click on the file to install. Next, accept the agreement and click next. Next. Yes. Next. Next one. Install. We need to wait a few seconds for the installer. Now VS Code has been successfully installed on my machine. Then click finish. Now we can go and check the version of VS Code using CMD. Then type CMD here. Type code version. The VS Code version is 1.95.3, and now we can implement the project step by step. First I'm going to explain the code, and then I'll show how to run the code, what techniques are used, and which libraries are included in the project. First you need to navigate to the location of the Smart Face Recognition System project, then replace it with CMD and enter code space dot. This will redirect you to VS Code. After opening VS Code, open the terminal. The terminal is now open, and next I'm going to install the necessary packages to implement the project. First we need to install these other libraries on the system. Dlib is used for face detection. CMake is used to set up your environment on the machine, and OpenCV is used for image processing and image handling. TinyP is used for handling the database. Face recognition is a technique used for facial feature extraction and face detection. Immortal is a basic Python library used to get a list of images from a folder. Scikit-learn is a machine learning framework used to build machine learning algorithms. JSON5 is used to handle JSON5. And then NumPy is used for handling arrays of data. And Tkinter is a Python library used to build graphical user interfaces. Now we can install the packages one by one. Now I'm going to install the packages using the Python command pip install r requirements txt, then press enter. Now it is installing, and it has been installed successfully. If any other Python packages are missing, you need to install them using this command pip install package name. I'm going to install one more package now, which is the face recognition models required for this tutorial. Just type the following command. When you are ready, pip install face recognition models. It has been installed successfully. First, I'm going to give a code explanation of a face enrollment process. Then I'm going to show how to execute the face enrollment module. First, we need to import the necessary packages for implementing the project. The packages are Tkinter, TinyDB, face recognition, CV2, OS, and TimeThread. Then we need to create a new folder for captured face images using the integrated camera. The folder name is dataset, and the subfolder inside is named project. Then it automatically creates a new folder for each person based on their ID. Here we are going to write a set of code in the enroll student function, and then we need to configure a button and then retrieve the user ID and username. If the user does not provide the information in the button, we should display messages like please provide person ID, please provide a valid numeric person ID, or please provide a valid person name. And if the configuration is set to default in the Tkinter window, then we don't want to show any error. If the file does not exist, we should provide some information. This file must exist in the config folder, and it contains the language information under the dataset folder name. The number of faces to detect and the total face count is 30, and the enrollment JSON is used to store the person ID along with the person name. And this is the face encoding file, which is used to store facial feature information in the encoding file. And Lu is used to store the person with numerical data. Recognition is used to store the machine learning model parameters. And for the detection method, we used HOG, so we should not use CNN. If you use CNN, it requires more memory, and sometimes the laptop can freeze. That's why we chose the HOG methodology. Next, we initialize the dataset path, and the file name is enroll.json, which is used to check whether the person is enrolled or not. If the person is already enrolled, we should display you have already enrolled. And the next function is process enrollment. CV2 video capture is a function used to process frames one by one. Next, create a folder to store the captured face images using the face recognition library. VD2 captures up to 30 faces. Then get your frame, flip the images and convert them from BGR to RGB. And generally BGR stands for blue, green, red. In Python, we refer to it as RGB, which stands for red, green, blue. This is the function used to capture face images, which includes the rectangle coordinates, starting point and ending point. Then make a copy of the frame, draw a rectangle around the faces, add some padding to the length, and store the images in the folder according to the ID. Finally, display a text in the Tkinter window that says your image is saving. If you want to stop the execution, just press the back key once. CV2 show is a function used to display a frame. So finally release all the windows and all the process frames. Once the enrollment is completed, we should display a notification in the Tkinter window saying enrollment completed for student name. Then reset the form. If any error occurs, we can handle it with an exception. So an error message will be shown. Then if you want to quit the execution, just quit. We set exit on the button, update the progress bar. If the count increases, the number of people also increases accordingly. And stop enrollment if you want to stop the execution, stop enrollment to stop capturing faces. Reset the form. This is the background color. The color name is gradient. This is the Tkinter window. The window is named face enrollment and its height and width are 800 and 600. The background uses a gradient color, and we should resize the frame according to the frame size. Then the Tkinter label is set to face enrollment. This is the label name to insert in the Tkinter window. The labels are we created person, ID, person name, and then add the progress bar label in the Tkinter window. Initially set 0%. This is for the frame button. Stop, enrollment, and reset and exit button. So finally we should use root main, so it keeps running continuously. And now I am going to install setup tools. It is installed successfully. Then I am going to run the code. PyEnroll, PyY. Now the Tkinter window is opening, and it has opened now. Now I'm going to enroll my ID. I'm choosing randomly. The ID is 3 and my name is Pandyan. Then I'm going to enroll now. Now my faces are being captured by the system in real time, and in addition to that, my image is also being saved and stored here for future reference. Now my faces are successfully stored in the folder. Then I'm going to click OK. Clear data. I'm going to show where my face images are stored. Open the dataset. This is my face, and my details are stored in the enroll JSON. My ID is 3. My name is Pandian, and the status is enrolled. Baby. Next, I'm going to run unknown face enroll py. If the person is not enrolled, then we should recognize that person as unknown. For that, I randomly took some famous cricketers from the internet whose names are Dhoni, Rohit and Virat Kohli, and now I'm going to run this unknown face enroll py. Copy the relative path pi, then paste it. We should enter double hyphen ID unknown in addition to double hyphen name unknown, just as instructed by the guidelines. Now it is currently detecting, and all of the images are being stored in the dataset. The next is, it is detecting now all of the images are currently being stored here. The next one is Virat Kohli. It is detecting now, and the images are being stored in the folder, and their information is also being stored in the database. The status of the enroll JSON data remains completely unknown at this time. Now their faces are successfully stored in the folder for future reference and easy access, as well as successfully written in the enroll JSON. Next, I'm going to look at the explanation and execution of face embedding extraction, as well as the other techniques used in face embedding extraction. Let's go through them one by one. Now, I'm going to explain what face embedding is. Face embedding is a technique used to extract the most important features from faces. These features can include the nose, mouth, and ears. And the output dimension of the face embedding is 128. Suppose you are feeding pixel data to the model and the model cannot properly understand the features, then those features are not meaningful. The reason for this can be explained with a simple example. If the image has a height and width of 100 each and it is a color image, then the number of channels is 3. If you simply multiply the height, width and number of channels, you get 30. If you feed 30 data points to the model cannot learn every single feature in the images. And this is the main reason for applying the face embedding extraction technique. Next, I'm going to explain the code as well as how to execute it. First, we need to import the basic libraries, Tkinter, Immutils, the face recognition library, Pickle, which is used to store feature data, CV2 for image handling, and NumPy for handling array data. First, we need to define the system configuration, which includes the folder path and the class ID. This is the function for getting a list of images from the folder. If the length of the images is 0, we need to display a message indicating that no images were found in the dataset. Then define two lists, one for storing embedding data and another for the known face IDs. This is the progress bar. Next, process your images one by one. First, we need to read the images using the CV2 library, then convert them from BGR to RGB, and then from BGR to gray, which means converting them to grayscale images. Then, expand the dimension to 1, extract the face embedding using the face recognition library, append the embedding data to the list, and finally save it in pickle format with the name face encoding data. Once the face embedding is successfully completed, just display it in the Tkinter window. Finally, exit the program. These are the button names. Start encoding and exit. Now I am going to run encode faces pi. This will open the Tkinter window and then we need to click start encoding. The encoding is starting now, so we have to wait a few seconds for the encoding to be extracted. Now face embedding extraction has been successfully completed. Total images 210. So that's done. Then exit. Now we can go and see the file. This is the face encoding file. This file contains two types of data. One is the facial embedding extraction data and the other is the corresponding person ID. Next, we are going to see how to train extracted embedding data using a machine learning algorithm in the smart face attendance recognition system. We are going to use a support vector classifier. It is one of the machine learning algorithms used for classification tasks. In the support vector classifier model, we need to provide both input and output to the model. Your input is the face embedding data and the output is the label data. This information needs to be provided to the machine learning model. For that, we need to import the necessary packages, Tkinter, label encoder, and pickle. Next, we define the configuration for the data, specifying where to store the pickle files and the folder name for the encoded data. Then, we need to load the face embedding data and define the label encoder, which is used to convert text into numerical values. We store the IDs as numbers, which is why we are applying the label encoder technique. Then define the support vector classifier along with some parameters such as gamma, kernel, and probability. These are the parameters used to boost the model's performance. Next, we need to fit the model. Fit means to train the model using the encoded data and their corresponding labels. Once the training is completed, we need to save the model parameters in the pickle file and the label path. Once the model training is successfully completed, exit the program. This is the Tkinter code, including the Tkinter window name, width and height. This is the basic information about Tkinter. Next, I will guide you on how to execute the training model. Now, I am going to execute the training model. Go to the terminal and type train model pi. Start training. Once the model training is successfully completed, click OK. The information is stored in the output folder as recognizer, pickle and lee, pickle. Now we can proceed to recognize our face using the trained machine learning model. Finally, we are going to run and recognize our faces using the trained machine learning algorithm. So let's take a look at it step by step. Finally, we need to write the recognition code. How do we train the model? So first, we need to import the necessary libraries. Tkinter, CV2, NumPy, Pillow, datetime to store the current time, Pickle to store and load data, T2 to store advanced data, and face recognition for facial feature recognition and facial embedding extraction. First, we need to configure the recognition path. It's already there. The pickle files are stored in the folder. Recognition, pickle, and the label path is LG pickle. Then we need to define attendance, JSON and enrolled, JSON. Once a person is enrolled for attendance, we need to store the attendance JSON created with the person's ID. CV2 video capture is a function used to process frames one by one. This is the method that makes it easier to store attendance information. Initially, the attendance information is empty. So make sure that the attendance is empty at the start. Then create a Tkinter window and the window name is attendance recognition. And then process each frame one by one. First, convert BGR to RGB. Then convert the images to grayscale. This is the process we use to train the model. Then extract the face locations from the images, draw rectangles, and feed the faces into the face encoding function, which makes it easier to extract the encoding data. Next, classify using a machine learning algorithm. Then increment the count. First, we need to check whether the person's attendance has already been stored or not. If the person's attendance hasn't been stored today, then it will be stored here. If it has already been stored in the attendance, then that's fine. The ID is already registered or enrolled. So this is the function for displaying images. Then start the video and exit the program. There's a start button and an exit button. Then finally, release the process frame. Now I'm going to show you how to execute recognize PY. Finally, I'm going to run recognition pi, which makes it easy to recognize enrolled faces. Just copy it, then paste it into the terminal window, and finally execute it to run. The Tkinter window opens. Then it starts detecting. I'm going to start. Attendance for Pandian ID 3 has already been recorded for today. I'm going to show the attendance JSON file. Pandian, and the date and time is 2024 12:10 and the time is 7:24. Now my colleagues are going to show their faces in front of the camera.
Okay. Since my face has already been enrolled, my face was recognized with the correct ID and my current name. So my name was correctly identified and recognized, and my attendance has been recorded in the JSON file here.
My colleagues and I have successfully recorded our attendance today. The name is Pandian, the ID is 3, their name is Kaushik, and the ID is 9. The attendance time is 19:24. Their attendance time is 19:33. Next, I am going to show data of unknown faces from the internet. Let's get started. Virat Kohli is now officially recognized as an unknown individual, primarily because he is currently registered and enrolled as unknown as per the official records at this time. Finally, I am going to run attendance enroll info check and delete ID. Copy the path, just paste it here, then press enter and then open it in this window. This is the overall attendance information recorded today. Pandian and Kaushik. This is the overall enrollment information for the face recognition attendance system. Pandian, Kaushik, Aswin and Dinesh. You can download it as a CSV file, enrollment, CSV, then click OK. You can also download the attendance info and save it. Suppose you want to delete any ID, you just need to enter your ID here, then delete. Person ID successfully deleted, then click OK, then exit. Now you can go on to check the data set. Attendance has been deleted. Pandian has been successfully deleted.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely help you in as soon as possible in a better way. Thank you.